Chemical bonding 11, sigma and pi bond. Essential idea: the larger structures and more in-depth explanations of bonding systems often require more sophisticated concepts and theories of bonding. Nature of science. Again, we're going to think about the principle of Occam's razor. Bonding theories have been modified over time. New theories need to remain as simple as possible while maximizing explanatory power. For example, the idea of formal charge. Let's take a closer look at covalent bonds. We've seen a few different types of covalent bonds: single, double and triple covalent bonds. The number of electrons or electron pairs shared decide whether it's a single, double or triple bond. A single bond has one pair of bonding electrons, a double bond, two pairs, a triple bond, three pairs of bonding electrons. We also know that you've got polar covalent and non-polar covalent bonds, and that's to do with the unequal or equal sharing of electron pairs. The polar covalent bonds have dipoles, and the electron cloud shifts towards the negative dipole of the more electronegative atom. And there's a third way to describe the type of covalent bond. A sigma versus a pi covalent bonds. A covalent bond is an overlap of atomic orbitals. The electrons in the s orbitals in these two separate hydrogen atoms move together, and the s orbitals overlap to form a covalent bond with a shared electron pair. This example shows a sigma covalent bond. Pi bonds involve a different type of atomic orbital overlap. Let's see if we can see a pattern here. Ethane here has 7 sigma bonds and no pi bonds. 1, 2, 3, 4, 5, 6, 7. It's got 7 bonds. Here, this molecule has 6 sigma and 1 pi bonds. 1, 2, 3, 4, 5, 6. It's got 6 bonds. It has 1 double bond. This bond here has 13 sigma and 2 pi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 bonds altogether, 2 of which are double bonds, and there's 2 pi bonds. Every single bond and every double bond has a sigma bond. Every double bond has a pi bond. So I'll say that again. Every single bond, every double bond, and indeed every triple bond has a sigma bond. Every double bond has a pi bond. Let's look at some examples. Hydrogen. We've got 2 s orbitals and an electron shared between them, and the s orbitals overlap to give us a diatomic molecule of hydrogen. Let's have a look here. We've got 2 spherical s orbitals. When they're moving close to each other, they overlap to give us a cloud of electrons where the 2 s orbitals have overlapped. Fluorine. We've got 2 s orbital and 3 2p orbitals in both atoms. They share these electrons through overlap of p orbitals to form a diatomic molecule of fluorine. So let's have a look here. We've got the 2 p orbitals, and on here we've got x-axis. As they move together, they would overlap to give to give overlap of p orbitals. Sorry. Now let's have a look at sigma and pi bonds. Just sigma bonds here, sorry. We've got the s orbital from hydrogen. We've got that p orbital from fluorine, both an unpaired electrons. When the s and the p orbitals overlap, you get hydrogen fluoride. So we've got the spherical hydrogen s orbital and the dumbbell shaped p orbital, and they overlap in the sigma bond. Okay, this time we'll look at sigma and pi. We've got 5 pi bonds because five sigma bonds and 1 pi bond. We've got 1, 2, 3, 4, 5 bonds all together. That means it's 5 sigma. There's 1 double, which gives us a 1 pi bond. Let's have a look at this hydrogen 1 and hydrogen 2 here, which I've drawn down there. And you've got carbon 1. So we're looking at this carbon here and these 2 hydrogens. And we've got this carbon here drawn down the bottom there. First of all, hydrogen 1 and hydrogen 2 are going to bond with the sp2 orbitals from the carbon. Okay, and that'll be sigma bonds. So there's overlap of the s and the sp2 orbitals to give sigma bonds. Next, we're going to get overlap with the sp2 and sp2 orbitals between the 2 carbon atoms. So this carbon 1 and carbon 2, the sp2 orbitals will overlap here to form a sigma bond, and they're sharing these sp2 electrons. Finally, we're going to get overlap of the p orbital from carbon 1, p orbital from carbon 2 to form a pi bond. Let's see another diagram here. Whoops. So what we've got the carbon 1 and the carbon 2 here, 2 hydrogens here, and you've got the s and the sp2 orbitals forming sigma bonds, the s from the hydrogen and the sp2, this carbon here, forming a sigma bond, and then you also have the sp2 from one carbon and sp2 from another carbon overlapping, form another sigma bond, and then above and below, the p and p orbitals overlap to form a pi bond. So these here are sigma covalent bonds, and it's an end-to-end overlap of orbitals. The shared electrons are on the axes between the nuclei, also known as the internuclear axes. All single covalent bonds are sigma bonds. What happens in a double bond? Let's look at it a bit more closely. One shared electron pair is in a sigma bond. The p orbital is perpendicular to that axis joining the nuclei. The 2 p orbitals then overlap, but they overlap side by side, not end to end. So you can see here, it's like this p orbital here and this p orbital here are side to side, and they overlap side to side. The shared electrons pair is in the region above and below the axes joining the nuclei. It's a pi bond. It forms the second bond of a double bond. So a double bond is just one bond, one sigma bond, and one pi bond. What happens in a triple bond? Well, obviously it's going to get a bit more complicated, and this looks fairly complicated, but bear with me. You can see first of all we've got a sigma bond between the sp and the sp orbitals from the carbon. An end-to-end overlap of orbitals, and it's along the axes joining the nuclei. The second bond in green is a pi bond. It's side-by-side overlap of p orbitals above and below the axes joining the nuclei. And then there's another bond which is another pi bond, and again side by side overlap of p orbitals in front and behind the axes joining the nuclei. So you can see this is the pz and this is the pz orbital overlapping to form a pi bond, and you've got the py and py overlapping to form a pi bond over the sp orbitals straight along the axes. A triple bond is therefore one sigma bond and two pi bonds. See if you can state the number of sigma bonds and pi bonds in each molecule here. Press pause and have a go. Okay. Well, this one has 27 sigma bonds, 3 pi bonds. 10 sigma bonds, 1 pi bond. 14 sigma bonds, 4 pi bonds. 25 sigma bonds and 4 pi bonds. Well done. Goodbye.